Hello, my name is Maria from mathmammoth.com. In this video, we're going to study parallel and perpendicular lines. First, let's graph a bunch of lines and observe which one of those lines are parallel or perpendicular to each other. The first one, y equals minus half x plus 3. This is in the slope-intercept form, so its y-intercept is here 3. Its slope is minus half, so that means like that. It goes through those 2 points. Here it is. Then y equals half x plus 3. It is the same y-intercept right there, but now it goes uphill through this point, 2 and 1. There it is. Those 2 lines are kind of symmetrical. They are mirror images mirrored in the y-axis. But are they perpendicular or parallel to each other? Nope. Y equals 2x goes through the origin. Then 2, being the slope, means it goes through this point here. Much steeper than those other 2 were. Next one, y equals minus 2x plus 1. This is a descending line since the slope is negative. Y-intercept is 1. And then slope being minus 2 means it goes like this. All right, do we see any parallel lines? No. Do we see any perpendicular lines? I see a pair. Over here, those 2 are perpendicular. Which ones were they? This one we just drew, and then this one which has a positive slope and y-intercept 3. That's this one. One more to draw. Y equals 2x plus 1. Okay, y-intercept is here. And then slope being 2, it goes through this point. Now we have some parallel lines. This last one is parallel with the one that goes through the origin, which was this one. So now let's observe these equations and see if we can see anything in the equations that would give us a clue as to how to tell if 2 lines are parallel or perpendicular. For parallel, we have actually looked at it, talked about it before. When the slope is the same, lines are parallel, and that makes sense because the slope is the steepness. Parallel lines have exactly the same steepness. But perpendicular, these 2 lines are perpendicular, and there's something special about their slopes too. The slopes are not the same, but if we multiply the slopes, we get negative 1. See here, half and minus 2. If you multiply those, you get negative 1. And it can be proven that that is always the case. When you have 2 perpendicular lines, the product of their slopes is negative 1. So lines that are parallel have the same slope. If 2 lines are perpendicular, the product of their slopes is negative 1. And we will use those facts now in these exercises. We will graph lines according to given conditions. The first one passes through 3, negative 1, and is parallel to the line y equals negative 1/3 x minus 5. It passes through a given point, and since it's parallel to a given line, then we know the slope. The slope of this line is minus 1/3, and so the slope of our line is the same. Passes through 3, minus 1, and the slope is negative 1/3, so we will go 1 and 3. Passes through this point here, so now we can draw the line. What is its equation? We can see that from the graph real easily this time, because the line passes through the origin. We know the slope, and therefore we already know the y-intercept, it's just 0. So it is y equals minus 1/3 times x. Next one passes through minus 5, minus 6, and is perpendicular to the line y equals minus 3/4 times x plus 2. All right. So it passes through minus 5, minus 6. Here's a point. And then it's perpendicular to this line, and so from that we can know its slope. You remember that those two slopes, their product is -1. So this number times our slope that we're looking for, multiplied, they give us -1. If I write it here, this slope times the slope we need equals -1. I can see now that our slope is going to be positive, so that the negative times positive equals negative. And then, to make the 3 and 4 cancel, I'll flip them, 4 and 3. This is the reciprocal of the 3/4. And then instead of negative, it's positive. So it's the negative reciprocal of this slope. So 4/3 will work. If I graph it, my slope is 4/3. It's going to be an ascending line. So it's going to be 3 and 4. So here is the line. And now its equation. For that, I need to once again go back to the y equals mx plus b and calculate the b. We can't easily read it here, so we need to calculate it. I need a bit more space. So we take this equation, and we now know the slope. It was 4/3. And in place of y and x, we will take the coordinates of the one known point, -5, -6. We've done this before, so you should be familiar with this technique by now. Here in this equation, we will then add -20/3. Some fraction math now. Okay, we will use the same denominator, 3. So I write this as -18/3. And now we can add -18 plus 20. That's just 2. So 2/3. Does that make sense? We have the graph, so we can go back and check. Does it look like b, the y-intercept is 2/3? Yes, it does look like that. So now we have the equation. So the final one is y equals 4/3 times x plus 2/3. Since it has fractions, it's kind of tempting we could even give it in standard form, right? If I do that, then I multiply both sides by 3. 3y equals 4x plus 2, and then from that, like that. That kind of looks simpler or cleaner. But either way, the y-intercept form or the standard form, both forms of the equation are correct and depict the same line. Alright, we're all done with this lesson. I hope it was helpful once again.